Hey there, math fans. We're going to talk about inverse trig function again. We defined the principal solution in the last video, so we mechanically now can solve something like this. Now I'm going to talk about how we can use the graph to get other solutions. And then I'll have a separate part where I talk about other ways to do this, but let's just talk about the mechanics. So first we can get the variable by itself, so let's do the principal solution. Subtract 4, divide by 3. So after a couple steps, you'll be here. Subtract 4 from both sides, you get 1. Divide by 3, you get a third. So now we're at a key moment. The moment we hit this button, we are going to lose some of the solutions. We know that, but that's fine. So we're going to say 2 pi over 35 t minus 10 is equal to inverse sine of 1/3. Now in this model, we're assuming we're in radians because that's how we've set up our general sinusoidal model. So it'll be a messy number, but that's the game. Okay, so then we can just keep solving. At that point, you could plug that in your calculator, but you can go from here. 35 over 2 pi, arc sine of 1/3, and then you can add 10. We just have to remember that that only gives us one answer. Now in certain applications, maybe that's all we want. It's just good to be aware that there are others. So that's going to give us a messy number. At this point, I would compute it. So I'll just bring our calculator in and see what we get. So we're going to do 10 plus 35 over. The most common mistake I see people when they're typing this in is dividing by 2 pi. I see this in a lot of situations. You got to put parentheses there if you're typing it all in. Okay, times arc sine, I'm in radians, yep, of 1/3. I think that's a 7. 1/3. Enter. Sorry, my lighting is not very good. I get this, 11.89. So I note that. So that is 11.893. And my students know that I like to keep more digits, but I just wanted to lay out the process here. At that point, we're going to switch to how do we get the rest of the solutions from the graph. That's not the only way to do it. Some students may have learned something else they can do in a certain step. To me, that requires a lot of memorization, but it's perfectly fine. I just use the graph. Now, typically in these problems, we're checking your graphing anyways, but now we get to practice drawing our wave. So remember, this is the start. This is the midline. And by start is where the sine wave starts. So if you can quickly sketch your graph, which we should be able to do at this point, you would have a midline at 4. Or a mean, we call it. You'd have an amplitude of 3, so it's going to go all the way to 7 and all the way down to 1. It's going to start at 10, and it's going to repeat every 35. So 10, 20, 35, about here. That's enough for me to draw it. And we also are just practicing that skill here of connecting with, so this is, not only is this one way to solve it, and it's a way that's fairly easy to remember, it's practicing the skill of graphing and connecting it. Now the question was asking when I was 5. Sounds like my age, but no, I'm definitely not 5. So we're going to do this. We're going to find these two solutions. The solution we just found is the one closest to where we started. So if we can just use a little bit of symmetry, we'll be done. So as long as this process seems and the graph looks like it's getting really big, it's not that much. The solving is this much, and it's more about this idea. So we know where that is, 11.89. So from this point on, I'm going to use the graph for the rest of what I do. Now I could get this next solution here, and that one's fairly easy to get by adding 35, because that's how long it takes to repeat. So if you wanted, you could get this answer. In fact, I could just write it down right now. Adding 35 is going to make it 46.89. And we could keep going and going and going. In fact, at this point, I could even write down a whole collection of general solutions plus 35k, where k is an integer. Add or subtract it as many times as you want. And I feel like that's where the graph really helps me. Just seeing the graph makes it easy to remember that. So there's one fly in the ointment. There's one problem, which is, where is this? And I think that if you thought about it for a while, you could deduce what it was on your own, even without us telling you. That's why I like this method. We're going to use symmetry. In fact, that's in the name. So I like a method that I can remember, that I feel confident I will remember. The thing you needed was to remember that the wave, I've said this every time I've graphed the wave in class, I've talked about how the wave repeats every 4. Meaning I've talked about how almost always when you graph, the first thing you do with 35 is you compute 35 over 4. So we're going to do 35 over 4. And that tells you how to maneuver between these fourths. Okay, so this would be 18.75. The next one would be another, but that's enough. I'm done. So if you know what you're doing, you're done, because you can find this gap. And then from that, get gap. So I like the simplicity of the idea. All right, so how am I going to get the symmetric solution? I'm going to do 18.75 minus 11.89. If I was on my calculator, I'm going to keep more digits. I'm going to compute what this is, and that's going to represent this gap. You with me? Then I'm going to add that on to the 18.75. Why am I adding it on? Because we're going to go equally far on the other side. Plus, and then we'll be done. So if you kind of look at it that way, it's a couple steps, yes, but it's not as big as it might seem. If you just look at the picture in the end, it looks bad. Okay, so we're going to do 8. Just a moment. I'm going to grab my last answer here. So there's my last answer, that 11.89. And now I'm going to do 18.75 minus that answer. And then I'm going to add that on. So this was, let me make sure you're with me here. This right here is 6.856. I'm going to add that on to 18. So plus 18.75. And I'm done. Equals, I like that I can, not have to remember too much stuff, do everything from my picture. Yeah, there might be some shorter algebraic way, which I'll talk about in the next video. But when I'm stuck, I come back to that. And then we can get the rest by adding 35 as many times as we want. So we would say this is the family or collection of principal solutions and everything you get from the adding on a period. And then we have this 25.61 if we round it, plus 35k. But I really do feel like our calculator gives us one answer, the graph gives us the rest. Of our inverse trig functions between sine, cosine, and tangent, sine's kind of the worst one. So we just have handled kind of the most complicated case when it comes to finding all solutions to an inverse trig. If you just want to remember something in general, use your calculator to find one. Remember that from there it's going to repeat every period. And then remember that you have symmetry you can use. So that's it. That's one example all the way through. I do have a visual of this, but I don't know if this is helpful. I'll pull it in. So just to recap, this is the visual. Made it slightly nicer than what I had. We had the peak. We found one solution. We used symmetry. So I don't know if this helps. We found the symmetric solution. We can add to get those other ones. We can find this solution. And we can keep going. So we can get as many as we want. Okay, I hope that sort of helps. Since that example took a little bit, I'll do a separate video with another example, but I hope that gives you the idea in one place.